Okay, looking at some other ways of interpreting integrals. They give us a function here, 4 minus x squared, so it's a parabola. Its max is at 4. It has roots at plus and minus 2, so that all makes sense. And they say describe the meaning of a function g if g is the integral from 1 to x of 4 minus t squared dt. Now, up here when we talked about this function, we called it 4 minus x squared. Here they've switched to 4 minus t squared dt, which doesn't really matter. This t, as you'll see in a moment, is something we call a dummy variable, meaning it doesn't matter what letter it is because it's all going to get replaced anyway. If you wanted to write 4 minus u squared du or 4 minus b squared db, that would work out fine, as we'll see very shortly. So we're supposed to figure out what this function is talking about. What would you think if, forget about that function for a moment, what if I just gave you, say, the integral from 1 to 3 of 4 minus x squared dx? What would the geometric meaning of that be? 4 minus x squared is this curve, and I've actually used x's here to make that a little plainer. And they say they're talking from 1 to 3. Well, we've seen that the integral of a function is the area under it. So this would be the area under this function starting at 1, and all this, and all this, and all this, and all this, and continuing all the way up to x equals 3. So in general, the integral of a function represents the area under that function starting here and ending here. What happens if we do this integral? Clear this out. Let's see what we get. This is the same idea, except we're starting at 1, as before, but we don't have a firm place to stop. The upper bound is x, which is saying we don't want to commit to a right edge yet. We're not sure where we want this to stop. So for now, let's just call this variable x, and we'll come back and tell you what it is later. Can we do that? Let's try it. Oh, I'll tell you right now, the answer is yes, we can do that, and it's not even that big a deal. When you're doing an integral like this, you find the antiderivative of 4 minus t squared, which is going to be 4t minus 1/3 t cubed. And then we're supposed to evaluate that at the upper bound and at the lower bound, which means at x and at 1. So our upper bound is x, our lower bound is 1. And that means we plug x into this entire expression, and then we do a minus sign, and then we plug 1 into this entire expression, and we clean up the result. So what does that give us? Putting in x's, we get 4x minus 1/3 x cubed. All I'm doing here is everywhere there used to be a t, I'm plugging in x in its place. And now we do minus. And now we run it again, but now everywhere there used to be a t, I'm putting a 1 in its place. So we get 4 times 1 minus 1/3 of 1 to any power is 1. Okay, so if we clean that up, we get 4x minus 1/3 x cubed minus 4 plus 1/3. And I suppose you could mash these together and say, and put this in descending order. Minus 1/3 x cubed plus 4x and minus 3 2/3, or 3 2/3, that's 11/3. So this would be our finished answer for g of x. And this is saying the area under this function, if you start at 1, is this much, and x is the right edge. So this is just another form of integral where we're saying, for sure we want to start at 1, but we haven't made up our minds yet where we're going to stop. Once we tell you the stopping point x, you can plug it in here and get any area that you want. So that's our g of x in cleaned up form. And then they ask a few follow-up questions about this. I'll just switch colors to set those apart. In the B part of this, they say, without doing any calculations, what would be the value of g of 1? Any idea? Tell you what, I'm going to ignore their instructions for a second and I'm going to do g of 1. I'll calculate it and then maybe if you're stuck, maybe the answer will shake things loose for you. If I put a 1 in here, I get minus 1/3 plus 4 times 1 is 4 minus 11/3. So that's minus 1/3 plus 12/3 minus 11/3 comes out to 0. Does that make any sense? We said that we're doing an integral which starts at 1, and now they're saying, oh, and this integral also ends at 1, which means the beginning and the end points are right on top of each other. There's actually no area in that space. This integral doesn't have time to accumulate any area because it stops the instant that it starts. So yeah, it does make sense that this integral would come out to 0, and we could have seen that coming. The only way you get some area is if there's actually some daylight between your start point and your end point. And, oh, okay, well, I ruined the surprise, but in the part C of this, they say now evaluate g of x and use it to verify the result in B. Well, we already did. If you evaluate this, it comes out to 0, and we saw that coming because if you have an area, even a curved area, that doesn't have any width to it, because it starts at 1 and ends at 1, then the area inside it can only be 0.